Earbuds and phones out, please. All right, what's formula for area of a circle? Huh? Area is equal to pi r squared. Absolutely. Okay. What's circumference of a circle? Is pi times the diameter, or how else can you do that? 2 radius, because 2 radiuses make 1 diameter. Would you agree with that? All right. Arc length. Well, actually, so area of the circle, here, we'll do this in the other color for you, is all the space inside, right? Okay. The circumference of the circle is the distance all the way around. What's the arc length? What are we talking about when we're talking about an arc length? It's like the area of the circle from here to here, or wherever. It's just a portion of it. Anybody remember the formula for this one? Okay, so the area, the arc length, is what portion of the circle divided by 360. So your angle measure. Okay, and that's usually in degrees. And times your circumference. So you'd have 2 pi r. What about area of a sector? Anybody remember that one? That would be if we're just looking for a certain portion of the area. And we take the area divided by 360. Actually, the area, I'm talking about from an angle measure. So the angle area times pi r squared. So it's whatever portion, the angle area. So for instance, if I have an angle that is 35 degrees, okay? Angle area. Okay, so if I would have 35 divided by 360, because that's what portion of the angle I have, times my area formula. Good? All right, what's the central angle? But I mean, what's the definition? Ooh, let me clarify. Okay, he said angle AOB, and then he said angle O. Can we use angle O? No, why can't we use just O? Because that's the circle. It's circle O, but you want to use all 3 levers, okay? All right, so, but what's the definition? How do you tell if it's a central angle? Because it goes to the center. The vertex is the center. Perfect. Okay. And what do we know about central angles? That makes them super easy. Both legs are radii. I agree with that. What else? Beautiful. The measure of the angle is congruent to the measure of the arc. So that means that the measure of angle AOB is going to be congruent to the measure of arc AB. Perfect. Is this all coming back to you now? Wipe off the spring break fog. Okie dokie. Inscribed angle. What's definition? What makes it different than a central angle? Goes all the way through the circle because the vertex is on the actual circle. Perfect. So this would be angle ABC. And what do we know about inscribed angles? They're half, absolutely. So the measure of the angle is equal to 1/2 the measure of the arc.
Wouldn't it be half of the angle is the arc instead of the angle is half of the arc?
What do you think? Which one's smaller? The angles, if you look at it, the angle's going to be smaller, the arc's going to be greater. So you could either say it's 1/2 the measure of the angle. So we could say 1/2 the measure of angle ABC is equal to the measure of arc AC. What's another way to think about that? There you go, love it. So the measure of the angle ABC is going to be equal to 2 times the measure of AC. You guys are thinking. All right, inscribed quadrilateral. What do we know, or what does it have to be? What thing do we have to know to make sure, so that we can say it's an inscribed? Inside the circle, and all vertexes are on the circle. Perfect. And there was some rule that we knew if it was inscribed. Anybody remember? Something about opposite corners. Not equal, but
Opposite corners of the
are supplementary, absolutely, perfect. Okay, so that means that angle A plus angle C is going to equal 180, and angle B plus angle D equals 180. Ready for new colors? What do you want? Blue and pink. Are we good? Ready to go to the next side? All right, what's a tangent line?
Isn't it like the one that goes like on the
Yeah,
side?
but what's that mean? When we
Like,
just...
like there's a circle and it goes like on the side of the circle.
Yep. It's outside the circle and touches the circle. Touches the circle where? Exactly 1 point. Yep. And what do we know about a tangent line if it touches at what do you call it? The radius. Because there was something special that happened. Huh? Perfect. Okay? So if it's tangent to the radius, then the lines are perpendicular. Good? All right, what's the definition of secants?
Is it the angle outside of the circle?
No, these are lines.
Oh, is it the line that goes like both sides?
Goes through the circle, and it can actually end on the thing, but it's comes from outside, okay, and touches the circle at 2 points, and they come from the outside. Usually, because if you think about it, this line's going to usually continue going, but you can stop them on the circle. Either one, that's fine. We learned back before spring break something about when you have this about your angle. What it was the rule? Anybody remember that? Okay, the measure of angle X is going to be equal to 1/2 the measure of arc ABC, so this part here, minus the measure of arc XC. Does that ring bells? Because it was the bigger arc minus that little arc, cut it in half. All right, same, same thing. If we have a secant and a tangent, the measure of my angle is going to be a half of the large arc minus the measure of the small arc. There's two things that comes into play when you have two tangents. First, our angle measure is going to be exactly the same. 1/2 of the big arc minus the measure of the low arc. But there was something else about two tangents that was kind of cool. You may remember. If they come from the same exterior, sorry about that, same exterior point, okay, like they do here, then they're congruent. So AX is going to be congruent to XC. All right, a couple more. Are we still using pink and blue? Huh? Sorry. Okay, what are chords?
Isn't that like from one point to the other point goes straight through the circle?
Yes. So they're inside the circle, and both endpoints are on the circle. Perfect. Okay. And to find segment lengths, okay, you can set up a proportion. If I make this circle T, okay, if I multiply, set up the proportion of one side, so QT times TS, I can set that equal to the multiplication of the other side, other chord, so RT times TP. Okay, so let's say this is 3, this is 4, this is 5, and that's X. That means I could say, hey, 3 times 4 is equal to 5 times X. And so then X is going to be whatever that divides out to, 1 point. No, I don't have my calculator, but that's okay. All right. And then for secants, let's make this point E, our exterior point E. Okay? Same thing. You do the inside part, so CD times the whole thing. So CD times CE, and that's going to be equal to the inside times, what do you think? If the other side I did the inside times the whole, what do you think this side's going to be? The inside times the whole, yeah. So AB times AE. Good? Last one. Okay. Since tangent and secant, they're kind of the same as far as well, we have on this one. Tangent's kind of the same as that because we want the inside to the whole. This time, you take it, multiply it by itself. And then multiply by the inside to the whole. Yeah, because I'm going to be AB squared. And then it's going to be equal to the two parts. So I'll have AC for my outside to go with the first one. And then CD for the inside part. Questions? Where is everybody at with this stuff?